right, so here's our second basic implicit differentiation assignment, just 4 more problems again. So this will be our walkthrough for those 4 problems. We're going to start off with this xy squared plus cosine y equals x cubed plus 2. And so we have to remember that we're taking the derivative of y with respect to x, right? Which means that every time we take a derivative of a y term, it gets a dy dx attached to it, because that's the chain rule. We're treating it as if it's a composition of a function, sort of, where we're writing it in terms of y, but then taking its derivative with respect to x. So we have to do the derivative in terms of y times dy dx. So for the first one, xy squared, we'll note that that's a product of 2 functions. So we start with the first function and multiply it by the derivative of the second function, y squared. Well, in order to do the derivative of y squared with respect to x, we have to first take its derivative with respect to y, and then we have to multiply that by dy dx. So we'll have x times 2y dy dx. Then we'll add to that just the y squared, which doesn't get a dy dx this time because we're not taking its derivative, times the derivative of the x term. Well, the derivative of x is just 1, so we'll just leave a y squared. Then we take the derivative of cosine y with respect to x. Well, the derivative of cosine y with respect to y would be negative sine y. But since we're taking the derivative of a y term, we have to multiply it by dy dx. And on the other hand, we've got the derivative of x cubed is just 3x squared. And then the plus 2, its derivative is 0, so it goes away. Now we will use our same general process that we always use here. We gather all the terms with a dy dx on one side and all the terms without a dy dx on the other side. So on the left-hand side, we're going to have a 2xy, just kind of cleaning up that, times a dy dx, minus a sine of y times a dy dx is equal to 3x squared, and then we have to move our plus y squared term over to the other side, making it a minus y squared. Then the next step is to just factor out the dy dx. So we have dy dx times 2xy minus sine y is equal to 3x squared minus y squared. And finally, we end up with just dy dx is equal to 3x squared minus y squared divided by this term that we had left when we factored out the dy dx. So 2xy minus sine y. And there is our derivative. All right, for this next one, we'll do the same basic process. We're going to take the derivative of xy squared. I think that's actually the same as the one we just did, but that's fine. So the derivative of xy squared should be x times 2y dy dx, right, using the product rule. That's the first part of the product rule. And then plus y squared times the derivative of x, right? And of course, that y squared doesn't get the dy dx because we didn't take the derivative of y squared. But this one does because we did take the derivative of the y squared in terms of x. The derivative of sine is cosine. So when we do minus sine y, that'll be minus cosine y times dy dx because we're taking the derivative of a term that includes a y. And then on the right-hand side, we've got a 3 for the 3x and a 4x cubed. That's the derivative of x to the 4th using the power rule. So we'll clean up the left-hand side, 2xy dy dx minus cosine y dy dx. But we will move that term that was on the left, the positive y squared, the one that did not have a dy dx in it, to the right-hand side. That allows us to factor out dy dx from the left. So 2xy minus cosine y. And then we'll just divide to get our final answer. So 3 plus 4x cubed minus y squared all over 2xy minus cosine of y. And there's our dy dx for this equation. So we've got 2 more here to do. First, we've got x cosine y plus y squared equals xy. Well, x cosine y is a product of two functions, so we'll use the product rule. That'll be x, and then times the derivative of cosine y. Well, its derivative should be negative sine y times dy dx, because we're taking a derivative of a y term. And then plus the cosine y times the derivative of x, and the derivative of x is just 1, so that's good as it is. Plus 2y dy dx. That's our derivative of y squared with respect to y is the 2y, and then we have to multiply it by the derivative of y with respect to x, which is dy dx. Then on the right-hand side, xy is a product rule. So it's x times the derivative of y with respect to x plus y times the derivative of x. Well, the derivative of x is just 1, so we don't need to include that. Now we'll clean up this side with on the left with all the dy dx's. And when we do that, we'll also move the x dy dx term over to this side and move this term that doesn't have a dy dx over to the other side. So we're going to end up with negative x sine y dy dx plus 2y dy dx minus x dy dx is equal to y minus cosine y. We'll factor out the dy dx, which doesn't really change much here. And our last step will be just to divide by everything that we had left when we factored out the dy dx. So on the right-hand side, we've got the y minus cosine y, and it's now being divided by negative x sine y plus 2y minus x. And there is our final answer. We've got one more here to go. Again, we've got a product rule here to start off with, x squared y. So that'll become x squared times the derivative of y with respect to x plus the derivative of x squared times y, right? And that 2xy doesn't get the dy dx because we didn't take the derivative of the y term in that portion of the product rule. Then we have a minus 1 for the minus x, the derivative of x being 1. And then the derivative of tangent y should be secant squared y times dy dx, because we're taking the derivative of a term that has y in it. Now we'll just gather all of our dy dx terms to one side this time. I think I'll just move this over to the right-hand side. So we're going to have 2xy minus 1 equals secant squared y dy dx minus x squared dy dx. That'll allow us to factor out the dy dx, giving us dy dx times secant squared y minus x squared. And a final answer of dy dx is equal to 2xy minus 1 divided by secant squared y minus x squared. And that should be our final answer. And that's the end of our walkthrough for the basic implicit differentiation 2 homework assignment. So hopefully you've got a good idea of how to do basic implicit differentiation problems, and can move on to some of the more difficult ones afterwards.